Now today we are going to discuss on your maximum minimum. So the points at which have its your maximum minimum is called the critical point, or the extremum points at which have its your maximum or minimum is called your critical points. In case of your function of single variable, we have that at the extremum value or extremum point, we have the tangent line will be horizontal. So here also, if we increase the number of independent variable, then that line transform to the geometric figure that is called the tangent plane. So the surface at which we have the extremum value, at that point the tangent plane will be the horizontal, and the point at which you have it, that is called the critical point. So we are going to solve some of the problems to find out the critical points and different type of your critical points. Now whenever we are going to find out such things, we have various methods we will follow to find it out. So let's we share that. Okay, so let's sort that one. And also the thing is, if we are considering the gradient of a scalar function, so that also gives you at a point where we are getting the maximum rate of change of that function. So whenever we are going to compute that of your for a scalar valued function, that grad f, or we can say that del of f, where f is a function of your x, y, for simplicity of this we are considering, you can consider also z, then you can have your f of x I plus f of yj. In case of function of several variable, we have it. Now if you are considering that they are equal, so for your extremum point, that functions will also becomes to 0. So that implies that your f of x equals to 0, which is equals to your f of y. So therefore, to get the critical points, we need to compute that fx equals to 0 and fy equals to 0, because this represents the rate, or moving towards a point, so point having maximum change of rate of change. Okay, so that's why to find it out, the critical points, we are computing that fx equals to 0 and fy equals to 0. So we solve the problem that find the critical points. Critical points for generally we denote that f xy equals to x square y square x. So to do that, we find out that zx equals to 0 equals to zy, and that gives you for zx you have 2x.
Sir, have you shared the screen?
Yes, it's
Sir,
not
but it
shown.
is not showing.
Okay, wait.
Showing,
No,
sir.
sir.
Sir, it's showing. I think it's his
No, sir, it is showing. Sir.
Okay, I am
network
sharing
issue.
once more. I am saying once more. Is it now?
Yes, sir. Now it's
Okay.
Yes.
visible.
Yes.
Okay. Okay. Plus y square zy, which is your x square plus 2x 2yx. Both of them are 0, so we can make them equal. So therefore you have 2xy plus y square equals to 2xy plus x square, and that ultimately gives you x equals to your plus minus y. But so for some point, that is zx equals to 0, you have the point y equals to 0. So for y equals to 0, you have one point. For y equals to 0, you have the point x equals to 0. So therefore the critical points, all the critical points are lying on all.
Sir, S equal to 2 minus sir, plus minus 2 minus.
Which one? X equals to plus no,
2, sir.
x square, that is y square equals to x square, so x equals to plus minus y.
Okay, sir.
So the critical points are on x equals to plus minus y. But if you consider the point for your x equals to 0 and y equals to 0, that is the point 0, 0 is also your critical point. 0, 0 is also a critical point. Now, for this point 0, 0, for this point 0, 0, if you are considering the nature of it, so we can see that z has its form. You have that is your y equals to x near of your 0, 0. So therefore you have, if you put it y equals to x, then you have it is your that is also x, so that is x cube, that is 2x cube. So therefore if you have that both the values of your x. So if your x is positive, we are getting the positive value of x, z. If your x is negative, then the negative value of z. So this takes both the positive and negative. So this takes both positive and negative value of z. And since
Sir,
it takes your, yes, both positive and negative, so we can claim that it doesn't have its your extremum value. Though the point is your critical point, it doesn't have its your extremum value. Say, therefore,
Sir,
yes,
sir, can I say that the critical point is that point which will be satisfy the x equal to plus minus y?
critical point is that point which will satisfy the x equals to plus minus y. This one.
Yes, sir. Like a 1 comma minus 1,
Hmm.
1 comma 1, 2 comma 2, 2 comma minus 2. That is the critical point also.
Huh.
Because it is the satisfy the equation x equal to plus minus y.
If you're considering that x equals to 1, y equals to comes to your 1. If you consider the line y equals to x, if you consider the line y equals to minus x, then for x equals to 1, you have y equals to minus x, so y is minus 1. From there also you are getting. That depends upon the values you are considering, the line on which you are considering this y equals to plus minus x or x equals to plus minus y. On that line the points are can be considered to be the critical point for such functions. Okay.
Okay, sir.
Oh, so
Yes.
the point 0, 0 also lies on x equals to plus minus y. So why have you mentioned it separately, like
Oh,
0, 0
yes,
is
we
the
have mentioned it separately because near about the point 0, 0, you can have the function which has its both taking both the values. You have that positive and negative both. Clear. So because of this presence of positive and negative both the values, we could not be clarified because we have the result that if you are considering for all those values, if you consider that x minus x0 is a point of your critical point r, then your f of x comma y0, if you fix y0, that is greater than equals to f of x0 and y0, this thing will happen. Then you can consider that this f of x is equal to your g of x. Then for all those x which satisfy such criteria should have its value more than some value, but in this case we could not be bound this one. Okay, so therefore at the point 0 0 the function has its special nature. It is a critical point, but it doesn't have it your maximum or minimum value. Yeah, in this case, if this will happen, then we can say that the function gx has its your minimum at your xg.
Yes, sir.
Yeah. So we can say that the critical point doesn't have its your extremum value. So at 0 0 z has no extremum value, and such a point is called your saddle point. Extremum value. So the point 0 0 is now is known as saddle point. So therefore, once we are getting the function to be your the function has its your critical points, we could find out the what are the type of the critical points, whether at that critical point whether it has its your maximum minimum value or it is not. So depending upon that we can be clarified. That clarification we can be done by some process. Yes.
Sir, here 2x cube is came like for x is equal to y, right? Sir, if I do y is equal to, y is equal to minus x, then it will be 0.
0.
The
It will
answer
be
is
0.
2x cube or 0 or the 2y cube or 0. Why the negative value is also coming? You said that this takes both positive and negative. What about negative value? I am not getting that part.
No, no, you are considering that y equals to minus x. Y equals to minus x. Then you are getting that value is equal to 0, but y can take its value negative.
Okay, sir. Yes, sir. Yes.
Okay.
Sir, also repeat that part. For y is equal to 0, why you took that? That step.
Yes. Is it?
Sir, how do you consider that for y is equal to 0?
Y equals to 0.
Yes, that step. After x is equal to plus or minus y. Why we
X
have
equals.
considered for only
So
y
you just
equal to 0?
you just replace that your x equals to plus y. You can have that of your x equals to plus y. You have your 2y cube. Okay, now once you are getting that 2y cube, if you consider that y equals to 0, then it will be 0. But if you consider that some value, you have taken that x equals to minus y, so you can take its positive value of your x.
No, sir. So here for considering y is equal to 0, it is a trial and hit method or it is sure.
No, it is a trial and hit method, but what we are showing that there are some critical points for which you don't have the maximum value. Just for that the example is. Okay.
Okay, sir. Thank you.
Another one from the critical points. So and in this case, if you do the differentiation, you will have the solution. You just verify that is x equals to y equals to 0, and the points lying on your points on the unit circle we will get. at the points for it. You have that critical points. Now at which point you have the maximum minima, that we need to be verified. So how do you test that? What type of points do you, the critical points are, what are the types of the critical points are? So for that we need to take help of the function of several second order derivative. So for that, the points critical points of and that type. Okay. So first we need to find out the critical points. For that you have to do that fx equals to 0 equals to fy, and that gives you the equations for your fx equals to 0, 24x plus sorry, x will be minus 12y equals to 0. Another one is 3y square, I think 3y square minus 12x equals to 0. So now if you are going to compute this one, then this will give you need to find out the points. So this will give you y equals to 2x. So that will give you y equals to 2x, and that will give you y square equals to 4x. Y square equals to 4x.
4 critical points are 0, 0, 0, 2, 1, 0, 1, 2.
Okay, so you have the critical points, that is 0, 0, 0, 2,
0, 2, 1, 0,
1, 0,
1, 2.
1, 2. So now you see that if you use that all four, both of the equation must be satisfied, but the case of if you are considering these two will not be satisfied. That is 0, if you put that for x, you will not be get that y is equal to your 2. Okay, if you are considering that putting y is equal to 2, that is y equals to 2, x comes to your 1. Okay, y equals to 2, x comes to your 1. So this point will be considered, but that will not be satisfied. Again, if you consider that x equals to 1, then y comes to 2. X equals to 1, y comes to plus and minus 2, even though the minus will not be considered. Because if you consider the minus, then it will come to the negative of your x. So the points will not be satisfied.
0, 1, 2, sir.
0, 0 and 1, 2. These are your two critical points. Yes.
Yes, sir.
Points. So now we need to be verify the types. So whenever we are going to do the types, we have to find out that fxx, that comes to your fx, I have not computed, that is your fx, I think. So that is 24. 24. Fx, okay, fxy. So fxy means
Minus 12.
minus 12.
Fyy 6y.
Minus 12, and fyy is your 6y. Okay, so now we have to
0,
yes.
0 at minimum, sir. 0, 0 minimum point, sir.
0, 0 is the minimum point. So what we have to do, we need to use one discriminant that is denoted by your d, which is defined to be ac minus b square. Okay, we need to find compute this one, but that ac is equals to your fxx fyy minus f of xy its square. This is equal to, so if you consider fxx, that is 24, fyy minus 12, fxy is minus 36 y square. So that must has to be first thing is that must has to be
Sir,
your negative.
FYY
Yes.
is 6y, sir.
Sir,
Fx is equal to
FX,
minus.
FYY is 6y, sir.
Fy, okay, right. Fyy is 6y. This one is minus 12 square. That means 12 square.
144.
144. So this comes to 144y minus 144. So now for the discriminant, if you're getting that d equals to ac minus b square is your less than 0, and your both fx and fy is your whatever the value of it. If it is less than 0, then that point is said to be your saddle point. So at the point d, at the point, if you consider the 0 0, it comes to be your minus 144. So that is your less than 0 for all, I mean at that point 0 0, not for all. So this is your saddle point. And if we consider that d equals to ac minus b square is greater than 0, then we have to check that whether your a is greater than 0, a or c is your greater than 0 or less than 0. If a or c is your greater than 0, then that it has its your minimum value. If it is less than 0, then it has its your maximum value. That means the extreme points are being considered. So for ac minus b square, we are getting ultimately this expression. So we have already considered this 0 0. We have another point, that is your 1 2. So for d1,
Yes, 0 0 saddle point, sir. 1 2 is minimum point, sir.
1 2 is the minimum point. So how much you are getting that one? That is your y is 2, so it comes to 144 again.
144, sir.
Now what is your a? A is your fxx, which is comes to your 24.
24
And b equals to, I think b or c. B is your c. C is your fyy. Which is your 6y, and in this case y is your 2, so that comes to your 12. So both of them are positive. So therefore the point 0.12 is minimum point. Now the thing is this expression ac minus b square, we are getting to be in the discriminant for to find out what kind of this the extremum or the critical points is, that can be explained by your Taylor series expansion. So if we have that function f of xy, if you are going to expand it with respect to the critical point ab, then we can have that expression. We are getting that a and c means ac minus b square will give you that what is the nature of that point, what is the nature of that critical point.
I have
We
one
can,
question.
yes,
Sir, if fx is equals to 0, then what we will conclude from this? If double
if
derivative with respect to x is 0, means
if
a is 0.
uh, in that case, if you are getting that a is equal to 0, it will not be conclude anything, because you can see that that the expression we have written here, if you are getting that d equals to your ac minus b square, so if a is 0, that means this will goes out. Okay, so minus b square we are considering that time. So minus b square is your less than 0. It must always to be your less than 0. Then we have to consider the criteria for your what will happen, you are saying. I think, is it your mean by that if you are considering a equals to 0, if you are considering a equals to 0, then it must be come to the saddle point, because if your a equals to 0 the case, then we are getting d equals to minus b square every time. So b square is positive, negative of minus b square, that must be always your negative. So that must be your saddle point. Is it?
Okay. And sir, one question more. We are
Yes.
finding the local maxima or local minima points, na?
Yes,
Not
yes, yes.
absolute.
No, no, no.
Okay, sir.
At that particular point
Sir,
we are
so
calculating. Yes.
can you once again explain why at D00 it is a saddle point?
D00 is a saddle point because we have the criteria. Then you have to go for your explanation of that. What I am saying. Suppose you have a function. I am saying that function f of xy. You are considering that the point AB. Yes, we consider that because it will helpful. That AB is your critical point. Suppose. Now, around this AB point, we can have the Taylor series expansion. If you have considered this one, that f of a plus x plus, comma, b plus y, or x plus a and b plus y, then is this equal to your f of ab? Just recall the Taylor series expansion, then it is equals to plus, we can have x
Or x minus a into fxab.
x minus a, then you have fx at the point AB
plus
y
y
minus
b
b fy ab, and then plus you have that square. So now if you just change these 2 points just for our simple expression, if you consider that the point A is equal to 0, it will be better. B equals to also 0, it considered to be your x is considered to be your x and y is considered to be your y, then you can have the expansion will look like f of that
So
is
at 0 0 we get Maclaurin series, right?
we are getting the Maclaurin series. We can have that is your 0, so x and y, which is your f of 0 0, plus this comes to your x fx plus y fy, is this at the point 0 0, of course, then plus x square f xx 2xy fxy,
1 by 2 factorial.
of course, 2 by 1, thank you, factorial, plus some expression which is of your order 3 onward, so we can give it that the remainder 2, and since it's have of your lower degree, means the changes are yours very small, so we can consider that this has its no contribution. This is a constant term f of 0 0. If you replace that x and y by your 0 0, you will get a constant term. This expression is comes to 0 because you have said that the point 0 0 is your critical point. Then you have this function only, okay, and we are reducing this term also, that is a higher order term. Now if you consider this one, this is now to be a function of your single variable, that is your g of xy. This can be considered to be a function of your x and y, and here from the analysis curve starts. Now we are going to find out what are the critical points for your g of xy. So whenever you are going to find out, again you need to find the gx and gy. So if you go for your finding, then you can have this implies gx is equal to 0 equals to gy. Here from we are representing that your f of xx to be your a, f of xy to be your, we have represented I think b, yes, that is your b, f of yy is your c. So what that function is, your function g of xy, it comes to ax square 2bxy plus cy square. Now if you're considering that gx and gy equals to 0, you have the 2ax plus 2by equals to 0, and another one is 2bx differentiating with respect to y, so 2bx to cy equals to 0. Here from whenever we are going to find out the expression for your x, means for your point x0 and y0, so we need to be solve it. So whenever we are going to solve this one, we are getting that if you multiply this by your c and this by your b, so these two will be cancelled out, then you have that ac minus b square, the term will come up, ac minus b square whole into some point x equals to 0. So now since we consider the thing is your this expression is not equal to 0, because if this one is equal to 0, then you can have any values of x, such as if you consider the just we have considered that the expression of your the points lying on the all over the point over the line, that is y equals to plus minus x. So they are the points, all these points are your critical point for the function g of xy, and it is not exactly one point, you can get many points. Okay, so if you have that this expression is equal to 0, then that time x has its many values, many solution. But if so, we are considering in general that ac minus b square is not equals to 0 in general for local maximum or minimum. This one is here not equals to 0. Now for this not equals to 0, only the possibility is either your positive or negative.
X equal to 0.
Yes. Okay, so that is your positive or negative. So depending on now the nature of this ac minus b square, ac minus b square is positive. Now again what the things come up that is what are the values of your nature of your a and c. So if you consider that the case what someone is saying that if a equals to 0, or if you are considering that c equals to 0, then this case will not be considered here, because we are getting that minus b square is the case which is comes to be positive, and that is not possible, it's not possible. So the case is therefore we have to consider a is your not equals to 0, or and of course and it's
C
not
then
that
or
far,
0.
c is also not equals to 0. So again for this criteria, if you consider that a is greater than 0, a is greater than 0, then you can see that for some value of c, if you are considering this one is your negative, then this two expression, that is sorry, if a is positive, c is negative, then we are getting that this expression is negative, this one is negative, so that it comes to again negative, but we are considering that is positive. So c must be positive, c must be positive, otherwise this inequality will not be hold. Okay. And for this expression we have that is your g of xx xy is your greater than equals to 0. Okay. Now for equality, we can write down that expression, that is your ax square plus 2bxy plus cy square. Cy
Sir,
square.
but there should be some relation between A, B, and C, right, sir? Because if A and C are both are positive, but A into C is
Yes.
less than B means B square value. I mean B square value is greater than A into C.
We are
Then
considering
if
for those values, of course. Because initially you have considered that ac minus b square is greater than 0. Now what are the possible values of your a and c? Okay, so you have started with this. They are positive. Okay, so under that circumstances, we are going to take that these are the possible things. And another possible things is that if we have both a and c is your negative, then also we can get this one is positive. Okay. And if this thing will happen, then we have the criteria that g of xy is your less than equals to 0, and that time we are getting it's to be your maximum at the point origin at the point 0 0 of that function. Okay. Now if you consider the another case, that is ac minus b square is negative, so if you have that ac minus b square is negative, so again we can have that ac a is your not equals to 0, because if we have that expression, if we rewrite that expression g of xy, we can have that is ax square plus 2bxy plus cy square is this, that we can write down in the form of some whole square. We have to rearrange it, not to recall that expression exactly, so some whole square will come up, and then the term ac minus b square will come up in the numerator, divided by a with divided by a though. So we are considering this a, that means some y square will come. Yes. So this is a positive quantity that you are considering to be some square, but that expression is depends only on this one. And also the thing is that implies your also a is not equals to 0. You could not get that a equals to 0 since we are dividing by this. So if you have this one, then again you can see that what are the possible values of your a and c. So if your a is equal to 0, it's not possible because we are dividing by a. So that case is out. Now the possible thing is your a is negative. So if you consider that a is your negative. Now for this negativity, we are getting that this expression a is your negative. This one is also negative. Whatever be the value of c is positive or negative, we are getting this expression is your negative. And this one comes to positive. So that negative to division of your negative, that is your positive, this is a positive. So that expression comes to positive. Okay. But this expression is comes to your negative. Okay, because a is multiplied with this whole square. So therefore at the point for x not equals to 0, at this one, if we consider that x is not equals to 0 and for y equals to 0, we have g of xy or x0. At this point, if you compute, you can have some expression which is your because x squared term is there, some y will be there, ax square. Is it x square? That actually I could not recall exactly. So you have that for x is not equals to 0, that case is there, that is a negative. Now for again if you consider some point, particular point we choose, and therefrom we can show that expression is comes to your positive. So therefore g takes its both the value. Once it takes its positive, another time it takes its negative, because this expression is your negative, because a is negative. You have chosen that a is negative. Similarly, if you choose some another point, that is some x equals to what that some points, I mean the line we consider passes through the origin, because we have chosen that x equals to 0, y equals to 0. So some line may be x equals to some constant minus k into y, something like that point if you choose, then we are getting that the value is comes to your positive. Okay. So therefore we are getting both the things. Once we are getting the negative, another time we are getting that g of this is minus ky and y, it comes to your positive. So that's why by considering this test that ac minus b square is negative, we can conclude that the function has its saddle point. We cannot conclude that the function always have its either maximum or the minimum, because around the neighborhood you have the points. Sometimes you are getting the positive quantity, sometimes you are getting the negative quantity. And if you choose now that for your a equals to exactly 0, then also you will get that the point to be your saddle point, because if your a equals to 0, you don't have that is x squared term, you have only this one, and for this you can also have it's your positive and negative depending upon your the value of your y. Okay, if you choose that. So that's why for your means AC minus B square of course is not equals to 0. So either it is positive or negative. For positivity we are getting the two expression, that is A is positive or A is negative. Depending on that we are getting the maximum and minimum. And for the negative portion, if AC minus B square is your negative, then we must get that point to be your the saddle point. Okay, that is the criteria we are going for. But the details things I could not recall explanation. Yes, okay. So now we solve the last problem. Far ahead of that. So find the minimum distance. This last problem. Find distance from origin to a point on the plane x plus 3y minus z equals to 0. So we need to find out the minimum distance from origin to the point to the plane. The point on this plane is this. So the distance functions is what? So the distance function d between 2 point origin and the point xyz on this plane is your d equals to under root of this one. So we are considering d square is the function, is your x square, y square and z square. So we can consider this is the function of your f of xyz. We have restricted that up to which that xyz will vary, that is that gives you under this relationship. So we can replace that z by your x and y. So therefore f of xy, it's shifted to your we can consider g of xy, which is equal to f of x y, and the relation of your z equals to x plus 3y.
The origin is satisfying the equation of the plane, so distance will be 0.
Origin is satisfying and the distance, yes, distance must be 0. Distance must be 0. From minimum distance from the origin to a point on the plane.
Sir, take it another plane like
Yes.
equal to
Equal to
4,
4,
equal to
Constant.
5.
Yes, yes.
Like that.
Yes, sir.
Yes.
Okay. Of course, that should have to be. I have taken that wrong. It's 4. Very good. So then we have this expression. That is z equals to x plus, okay, x plus 3y minus 4, which is your x square, y square plus x plus 3y minus 4, its whole square. So now this comes to a function of 2 variable. Now we could find out the critical points, and then we could find out the minimum distance, minimum value of that, because we are considering the function is restricted to be of your minimum, so that therefore we no need to be verify this functions has its minimum point at that critical. So for that we need to compute that of your g of x equals to 0 equals to g of y. This comes to your 2x, this goes out, plus 2 into x plus 3y minus 4 equals to 0. Another one is your 2y plus 2 into, that is 2 into 3, that is 6, x plus 3y minus 4. So we need to be solve these two. So we first find out the equation, that is your 2x and 2a. Okay, 2 will cancel out, that is 2x plus 3y minus 4. We have 2x plus 3y minus 4 equals to 0. Another one is your 6x, 2 will cancel out, so 3x and 9 plus 1, 10y, 3x 10y, 3x 10y, and the constant term is your 24, that is 12. Equals to 0. Now you just find out the point, that is x equals to some point x0 and y equals to y0. Yes.
X equals
4
to
by
4 by
11,
11, y
minus 4 by
equals to
11.
12 by 11.
4 by 11, y equals to 12 by 11.
Yes.
Minus 4 by 11.
Minus 4 by 11. Okay.
Yes,
Minus
sir.
4 by 11, y equals to 12 by 11. So once we get this one, we could find out that value of your z, that is z equals to, you have x plus
Minus
3y
4.
minus 4. Okay. X plus 3y.
Sir, S equal to 4 by 11, sir. Plus, sir.
Yes, the
Okay.
x equals to plus 4.
Okay, so you just find out the points. That's why I'm not going to solve. I need to be solved this one.
S equal to 4 by 11. Z equal to minus 4 by 11, sir.
Yes, x equals to
4 by 11. And Z is equal to minus 4 by 11.
4 by 11 there.
that is your minus 4. It comes to your minus 4 by 11 that you have. So now once you get that x, y, z, you can find out that d is.
Yes, sir. Under root 4 by 11 whole square plus.
Yes. All this. That gives you the
Under,
minimum value.
yes, sir.
Is that equal? Okay, so that's all. I will give you 1 or 2 more problems to solve. And then we will discuss in the next class.
Sir, please show, sir, slide 4, sir.
I'm saying.
Four, sir, 4.
It's there. On this one also.
Yes, sir. Thank you, sir.
Distance. The point. Okay.
Sir, I want to in this problem the stated above, fxy equals to 2x square plus y square. Here fxx equals to 0 and fyy is also equals to 0.
Okay.
So what can we conclude from this? Because we have said na, that fxx can't be 0.
Fx x is equal to
0 at 0, and 0 is the critical
and
point because fx.
what about your AC minus B square? First you need to that criteria whether it is positive or negative.
No, sir, 0 not, sir.
So if it is 0, no.
Yes, sir, it will also be 0.
Then we need to calculate the next order also. Until and unless we are getting that some values, because if it is equal to 0, then you have that many points. Okay. If it is equal to 0, we have that criteria that if it is equals to 0, then you have the many extremum critical values. A series of critical values is there. Any
Yes,
value
sir, 0,
can
sir.
consider.
Sir,
Okay. So
0.
if it
But
is,
what condition to apply for higher derivatives?
that's also the same thing. You have to compute that for the next order, third order, and then the fourth order. So that fourth order we need to be computed. But I think it will not be go for your fourth order. From
No,
the
sir,
second order
second
you
order
can
will
compute.
be okay,
Yes,
sir.
So
you
from
can.
third order, how will we derive the condition of maximum minima? That is the sir question.
From third order, you don't need to be go for your third.
For third order.
I am saying that you don't need to be compute for your third order. Once you are getting that fx and fy equals to 0, you just see that you have that one expression, that is e to the power minus x square minus y square equals to 0. Okay. So what are the values? So what we are getting, that is your some 4x, 2 into 2x, that is 4x. Then you have e to the power minus y square, that is number 1. Then plus, that is your 2 into x square plus y square. You have e to the power minus x square plus y square, and then for this one you have the 2x. Okay. So all these things you have this
Sir,
expression
minus 4x, no, sir.
2x. Why that minus?
Minus x square equal to minus 2x, no, okay, sir. First, no, sir, minus 4x.
Huh. Oh. No, we have the 2x square. 4x.
No, sir, in the second
Minus
term,
4x.
that will be minus 2x because e to the power
Yes,
minus
sir.
that is there.
E to the power minus x square, no, sir.
That should be minus. So if you
Sir.
Okay.
Starting, sir, minus 4x, no, sir.
Yes, sir.
you are differentiating this one.
Yes,
So
sir.
that,
E to
that
the
is
power minus x square by square into minus x square minus 2x, no, sir.
and a to the power minus x square. So that is, we have taken that minus, that gives you this one. This gives you minus 2x, and that for the okay, that is your plus. For this one it comes to minus 1, and for the minus x square plus y square it comes to your 2x. Is it okay? I will see this one later on and then I will give you the answer. Okay.
Then what is
Minus
the answer for the upper one, sir?
Sir, in
What
the
is that?
second term, after e power minus into x square plus y square, there should be minus 2x, na, sir. So that minus comes to the at the point of plus. That's what we are saying.
Yes, sir.
So that's why I have written here the minus is.
No, sir.
I
E
have
to the
written
power minus x by
Yes, sir.
square
Now
minus x
it's
square
fine.
minus 2x, no, sir.
No, sir. Now it's fine.
Now it's
Ah.
fine. It's fine.
Yes, sir.
Okay. So now you have one expression that you can bring this out, that is e to the power minus x square plus y square. So okay, that expression is also comes to 0. So from there you can conclude that e to the power, if you have this one, minus of your x square plus y square, it is your e to the power, sorry, it is equals to 1, sorry, it is equals to 0.
So that
So
is not possible because how can it?
if you're considering that that value is equal to your, okay, we are
X
considering
square
that is
plus
equal
y
Yes,
to,
sir.
square
That
equals to
will omit
0.
none.
Yes.
That
That is
it will
not
simplify.
possible
It will come
as per
4x minus 2x square plus y square into 2x, and the second will come
Sir,
like that. Then we'll find the points. It will not come directly 0.
that form we are not getting. Okay, how these points coming on, that the critical points are on the here, I will conclude and then I will send it to you. Okay.
Thank you.
Okay, thank you.
thank you, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.
Sir, have you taken attendance?
thank you, sir.
Sir left.
सर लीव कर दी